So there are some criteria to reviewers requested to fill by reviewers for proposals, which is a little bit more than a paper, and then typical criteria for a paper. But general train of thoughts is similar. So in the last couple of months, each group meeting we were mimicking that we are reviewers of each other, and there are some guidelines and expectations what reviewers should pick in the paper or looking broader in the proposal. So one should look if is there innovation, is something non-standard. Reviewer may decide to write in a report what is the most important result based on reviewer assessment, and it should be clear to reviewer how this work impacts work of others. Ideally, anything what we submit for publication has some originality and differs from others in the field. So if we are just repeating the same methodology or look at the same materials that someone else did in the past, it can go through, but it may induce noticeable criticism. So it should be either novel method or novel material or both. Also, reviewers are often invited to pick to generate a criticism on validation of the results. And the simplest example is if the provided results do have a reference point. Is there some simpler system or used method coincides with experiment, or maybe just computed observables directly matter to experiment, or maybe just there are general trends, or at least the observed trends do not contradict the common sense, but some level of validation is appreciated, and if one doesn't see it, it could be a reasonable complaint to the author. So for the methodologies, they should be logical and eventually innovative, and justify and lead to conclusions that others may trust. And also, the following statement is more typical for the proposals, but if playing the role of reviewers, we do see it in the papers, it's also a good point to focus at. If the author recognizes potential barriers, potential difficulties, and provides ways to address them, or just simply recognizes. So I can give an example when it doesn't, it is not present in the paper. For example, I'm doing first calculation with a certain method in my life, and I'm so excited with the result, and I'm just offering, like, look at my pictures. I don't care whether they love it or not, but look at me, I did it. So there are some results, and I want to believe they are best possible. So such approach is not ideal, and we should avoid it. Otherwise, reviewers will pick it up, and as we play reviewers, we may catch this. If author has intentions to identify possible problems, even if the method is really good. So healthy self-criticism is appreciated in the community. And here are some brief guidelines for one of the journals. So they request reviewers to identify new insight. They request that conclusions are supported by the data. And they just want some comments about match between how important the results and how many technical details, meaning that if the results themselves are not very important, then one shouldn't supplement them with 100 figures. So some balance. And often reviewers are invited to give grades, maybe not ABC as in education, but something similar. Like, is it like top, high, or moderate? And the by the end of the day, reviewer is invited to give the final judgment, and the first and last are very rare. So when reviewer is happy with everyone and suggests to publish as is, and not recommended and should be rejected is also not very often, but typically when author is fighting to get higher in the SMIT grades, so to get only some requests for cosmetic changes without further review. But quite often reviewer provides an invitation to change some calculations or change some analysis of the results, or provide additional sections in the literature review. So I'm not cutting this document to the end of each paper because it is underdeveloped, but I believe Amir and Mead were requesting such sort of comments in one of our previous meetings. Amir, Mead, was it answering your questions, or it was useless?
Yeah, definitely. That was useful.
Okay.
Thank you.
It's very helpful. Thank you.
Okay. Yep. Thank you. So I believe I did send this list, these links to everyone by in the email, but just in case, I'll show it in the chat line. And I suggest we go to readings of those materials that we didn't cover yet. So I believe the contribution by Mead is completely new for the group, and Amir has implemented noticeable amount of changes. And after we are done with reading, we'll go to discussion. In the works by Amir and Aaron, there are like marks in telling that we stop the discussion in the middle, so we'll complete the discussion. And if time allows, we may look on the draft of letter to the editor by Amir and check if there are some suggestions. Any criticism or suggestion for the, for the protocol? Okay, if everyone is okay with this, let's focus on reading and get back with when we're done and start discussing. Okay, let me invite everyone to resume in the discussion mode, if you don't mind, and we'll try to discuss whatever we can in a given time. Hello, Amir. Thanks for reconnecting. How are you?
Fine.
So maybe we should quickly go over Aaron's work, because we didn't finish it last time, and there were some comments left. So and then we'll. Yvonne, did you finish discussing your paper last time? Okay, then we'll maybe go to Aaron and Amir, because they are quite short, and then use all the rest of time to meet So um, here is the work of Aaron, and I see there are some questions about methodology. Yeah, we ended by the end of methods. And so, do you remember any questions to Aaron's way of delivering the methods? I'm asking because I'm fine with how it is expressed. Okay, quickly go through. So there are some suggestions from you, and I believe if one pulls it back and forth between Google Docs, some formatting can be lost. So maybe one needs to just make sure that the Word document is fine and use this Google Docs only as a guide. And I believe everyone is okay with this sigma prime, which stays for different spin configurations, different spin configurations. Or later on, we will get to work of Mead, and he is mentioning the Redfield equation. But in Mead's work, it is not, this dissipative term is not practiced. So we will find a way to mention Liouville von Neumann on one hand, but do not focus much on the dissipative part. So just a comment. We'll get to it later. Yeah, this recombination is really great to add. Thank you, Aaron. And later on, the whole group will probably repeat it and give credit to Aaron's work for this methodological novelty. So I wonder, would it be reasonable to have a consecutive notation numbering of the equations together with mathematical equations, like chemical or mathematical, they're still equations. I'm fine either way, but please consider to number them in the same way as previous. So, and how did we start the results yet? Is it all the results section? No, it's yeah, that needs to be details. So results should start in.
No, those should be results.
I feel that it is results, but I do not see. I know that now I'm acting like a bureaucrat who doesn't understand anything, but I do not see a label. Oh, results, yes. So I'm even worse than a bureaucrat. So results, good. Okay, so other questions to Aaron about results from new reading or from last time. Let me quickly go over. There are not much critical comments. I'm on the exclamations of in German, but there are some good points to mention. So analysis of that. Yes, it is good that this feature is mentioned several times throughout the paper, because it is quite a big surprise that the surface traps ST are bright rather than dark. It is very counterintuitive, and maybe the one of the experimentally found features of the perovskite that makes them outstanding. So experimentally, it is referred to as self-healing of defects. but here it's just observation that traps are bright, which is even if it will contradict to some other computations, it's a really unusual thing to mention. The mentioning of the reaction barrier is really great, and I think the paper should be sent out as soon as possible. But if one would decide to continue this direction, it could be an additional step to literally explore the potential energy for desorption or for the parts of this reaction. And later I add a comment which could be interesting to you. In what follows, Aaron is mentioning proton transfer between anionic and cationic ligand that makes them to dissolve easier. And the potential energy profile and barrier of the potential energy profile in exact numerical form could be interesting and important quantitative criterion, and could open the way to assess the probability of this proton transfer to happen at lower temperatures than it actually happens, same as Yulin did in rocket fuel paper. So if proton is transfers, then there is a chance that there is a tunneling. Tracking coordination bonds is great, and it is a second methodological feature that readers of this paper can import for the future research. Yes, extracting profile of potential energy to evaluate proton transfer could be an interesting extension, and one of the possible ways is to practice non-elastic band method. I know that Juvun is practicing it on a daily basis, and I don't know if Aaron did it in so if you decide Juvun is the best expert in the 200 miles around. Any questions to Aaron on discussion section? I'll quickly go. I think you already included this population damping in the methods and results, so maybe one needs to update, right?
For
or
for one of the models I did, the other one I didn't.
Oh, okay, I see. Changes in surface composition, altitude, band gap. Expected. And this is a great comment that will help the paper to pass through screening of experimental community experts. And this is a good, although it is already done by someone, it gives some recipe for anyone who tries to continue experimental research on perovskite nanocrystals. Are there any specific questions to Aaron's work on conclusion section? I do not have either. I typed some last week, so maybe when it's good that this unusual bright feature is highlighted, and hypothesis about power is also reasonable here. Just for curiosity, I do not have an answer, and not on a question, not only to Aaron. Are there some bright, some clear experimental signatures of proton transfer. Is it like pH or change of maybe NMR signal? I'm just giving a fantasy. But
Heat, I would guess.
uh,
It would be hard to measure, but like to do a calorimetry.
Okay. Is there would be there a change in the infrared FTIR spectra, like normal modes would change? Um, I, c- I cannot imagine myself in the skin of experimental reviewer, but I would ask this question: like, how does one know if this prediction is correct? What are the ways to check if it really happens? Although it seems very logical and natural, but just if you, in the meantime, while working on other sites, if you come with some ideas, could be relevant. Okay, yeah. Many thanks to Aaron, and maybe implementing some suggestions from previous week, and just focusing on the draft of the letter to the editor, highlighting both impact on experimental community and on theory community, like with some humble hope that this analysis of average bond lengths and recombination damping can be used by others in the community. Okay, Amir, I think next will be Amir. And we finished last time somewhere.
From from discussion section.
Okay.
Yeah, very good catch. Yeah, thank you. Maybe understand.
So other, I'm going to go over all marks, but are there any verbal questions or some emerging questions to discuss? If no, I'll go forward. So I didn't check your references one by one, but by talking of injecting charge and doping conjugated polymers, it would be reasonable to cite Alan Heger and other people who got Nobel Prize for conjugated polymers.
Unfortunately, I haven't heard directly from this guy. My bad, but sure, I will check.
Yeah,
And
just look for like in Web of Science, and it doesn't need to be tightly connected. They when they were doing their major works, like at the beginning of 80s, there were no your polymer was not synthesized yet. So they have just some general comments on properties of conjugated polymers and synthesizing them with catalysts. There is a fun story that it was discovery of conjugated polymers. It was a error of graduate student who was sleepy and put 100 times more catalyst in the solution than it was prescribed, and suddenly the beaker covered by silverish like metal cover from inside, although it was planned to have some polymers, and it was purely organic. Colorless after doping. Please double check.
Yeah, we discussed it previous week. I for this part I had experimental work, and I just borrowed this maybe verbal language from their paper. So if you think it's not right, we can delete. But
no.
I didn't know that about that. But just the check with that reference.
So if there are no transitions in the visible range, it will appear colorless. And there are some materials with very low gap, which are colorless, but it is quite unique materials. The typical example would be where this Indian tin oxide glass. So this material is metal by definition. It has zero gap and it conducts electricity, but it doesn't have transitions in the band gap and appears transparent. But it is quite rare and unique. So this, if you are confident in this observation, then it should be treated like, oh, what a surprise.
Yeah, for that reference, for instance, mentioned that the addition of dopant to this conjugated polymer bleach the polymer model. They use this word, so I just replaced that by colorless.
That's good, but you can mention that it is not typical for most materials. So it is quite unique feature and it's interesting.
Okay, sure.
So that a reviewer who is not expert in this area doesn't argue that it is something that typical. So I'm happy and fine as it is written, but if you have interest in STEAM, maybe look again for literature on quasi-particles for semiconducting polymers, not necessarily your polymer, something very simple and early. And there could be discussions on how the geometry changes upon charge injection, doping, or photoexcitation. And
you mean computational?
Either computational or theoretical. It was considered as a major challenge for theory and not possible to describe. I'm not following each tiny piece of literature these days, but there was a time when it was considered a big challenge, and any step in this direction was applauded.
Okay.
So maybe your paper has more value than you appreciate yourself.
Sure, I will double check.
Okay, here I just put that it is mimicking rather than literal modeling of the doping. So again, for the literature, one may look for basic polymers like PPV, polyphenylene, which has a lot of literature. Polyacetylene is cool. Nobel Prize was given for it, for polyacetylene, but it is not useful for any applications. And PPV is second popular, and it is possible to use for. It was used in some of applications. So,
Dr. Killian, in the results section, we cited several experimental papers that directly use this polymer model.
Good, thank you.
I'll
double check.
Yeah.
Thank you. Any additional questions to Amir? Okay, if no, before we go to needs, and we will try to do as much as possible, but it will not be possible for everything for today. Here is the draft of the letter to the editor drafted by Amir, and it is a good draft which doesn't need much of the edits. So
can you provide me more comments on your question,
yes.
Dr. Killian, please?
So by reading it, I do not see that the paper addressed any challenges. So even if it didn't, we should brag that something was a challenge for community, and your work did help to overcome.
Okay, I got it.
to look at from this angle. Summary is really great. It has a little bit too much focus on technical details and applications. And if you have Steam, try to maybe highlight the methodology. Like if there are, if by comparing with literature you see that we do something different, more
Maybe using periodic model or hybrid functional could be the difference.
well, just think again. We are trying to submit as soon as possible, but it is not count on minutes. So if you just think on the background and add more, how do you judge novelties in methodology? And myself and Dr. Shah will suggest reviewers that if you have some ideas, please try. And
I already talked to Dr. Shah. Totally from our side, we have 2 suggestions. So maybe
you can plug them in, and I will.
You will revise by yourself.
Yes.
We'll add your reviewers. Okay.
Yes. Okay.
Just one question: should I provide more than 2 reviewers, or you already have some guys that you can suggest?
The larger, the better. If authors provide multiple reviewers, the editor gets an impression that authors are brave and ready to accept criticism from unbiased audience. If you suggest 1 or 2, there is a suspicion that we suggest our friends who will write positive reviews anyway, and reviewer may try to use someone else.
Okay, I know some experimental guy in this field, and I'm eager to maybe mention them. What's your opinion?
Okay, yeah.
Okay.
Any questions to Amir on this? If no, let's go to Mead's work, and we will not be able to finish it today, but at least we'll start. And I believe Mead can read through the rest of the comments. So I see Aaron has a question to the abstract. Is it something to discuss, or just Mead should use your verbal formula?
Not a question. It's just a suggestion to like reframe the idea.
Okay, good. And I have the cosmetic suggestion. Reviewer references are not typical in abstract. If you use reference, you need to give the full, not authors, but only paper year. And I think under irritation, you mean irradiation, right? Through the paper. Okay. So there was a question of Amir about number of subsections. In the very final version, one may remove the subsection, but it seems a good scaffold just to set up logical arrangement. So, are there any bright, well, everything is bright, but any emerging comments to introduction to focus on, or should we just go line by line? Yes, Amir, I was asking Mead to cite references with this comma separately, because at some point one may need to reshuffle them and use only like first 2 here and 3 others elsewhere. And if they merged, it is more complicated. In final version, they will be merged. Aaron is asking if thermal energy can be used to closed loop up cycle. Need? And your microphone is muted.
Well, any way to, I mean, a closed loop system is just simply like you incorporate a product into a material you use that material, and then you constantly reuse that product or that material over and over again. And so, can thermal energy be used for these closed loop systems? Yeah, it's possible, but
Is it generally possible, or as a member of polymers and coatings department, you know examples where it is already implemented?
yeah, I mean, there are some areas where it's the heat of one reaction kind of gets used to initiate another, but it's pretty rare, so it's not really used effectively at this point. Like
Okay.
this thermal
So I
energy.
just guess that if one starts to heat, then instead of decomposing on original monomers, it will start burning or going in the non-productive direction.
Non-productive direction. That is correct. Yeah.
Um, uh, Yun, do you understand what Yun is asking?
Yes, I did explain a step process somewhere. Yeah, actually, initial, and then it's a secondly, and then finally. So it's actually the sentences following. So is that bad to say that, or
So
Shots are not very clear. So
Huh?
first read it, it's very confusing.
previous research is recovered, but okay. Okay, I can reword it differently. Yes, I can.
Okay, yep. Let's go forward. So Yun tells that it looks like ensemble of trajectories. Did you do ensemble of trajectories or just one?
I believe I just did one, but can you clarify the difference between ensemble and singular?
You would like to explain yourself, or you would like me to try and you correct?
I guess my question is here, because you mentioned you would like to observe different trends under different photo excitations, right? So in this case, you should have a wide range of trajectories with different initial conditions, leading to different reaction pathways and also reaction products. But here you only have one trajectory. I'm not sure the hypothesis is correct.
Okay. Yeah, maybe I need to do better job of explaining our process of doing what, from my understanding, an ensemble of trajectories, which what we do, but then we highlight just one or two specific ones that correlate well with experimental data. That's what's coming to my mind.
Okay, so I was observing this work in progress, and to my understanding, Mead computed exactly what Yvonne did mention. So Mead was screening like several dozen initial conditions and exploring different pathways. But here in the paper, he is demonstrating only either most typical or most productive one or most vivid reactions. But because even with these limitations, it gets quite lengthy. But maybe you can verbally tell something like this, so that we screen dependence of products on initial excitation, and here in the first paper in the series we report only most representative cases.
Yeah, since I don't have it, could you actually comment on his comment and just suggest to, as a reminder for me to incorporate that comment?
Yeah, sure.
And then yeah, I can do that.
Uh,
And then I know we had mentioned I could almost brag about all the other trajectories that we looked at, in supporting information, or is that something more explained through methods, discussion, or introduction?
If you start discussing each or few more trajectories, it will be unreadable. It will be a book rather than paper.
Hmm.
But you shouldn't be shy telling that we screened like 30 trajectories. They show different pathways, but we illustrate most interesting ones
Hmm.
to please the readership or whatever.
Yeah, should that be in the introduction, as in like around this hypothesis area, or should that be in the discussion?
It's your choice.
Okay. Yep. Yep. Okay. That sounds good. Yeah. Yeah.
Amir thinks previous experiment in wet environment is not clear.
Yeah, I was trying to word it as, I mean, their work was dealing with H2O as a solvent, and
No. I am my, Amir, please correct me if I'm wrong. I think uh, in this verbal formulation, it sounds like if the authors of the paper number one are co-authors of this paper. It looks like it is a continuing effort of the same team. And by now, they're not invited and they didn't contribute to this paper. It's more like we are referring to literature data on previously completed experiments. So it's just a tone of the verbal statement. Amir, did I interpret your question right?
okay, I should highlight as in work that has been found. Not saying. Yeah, I can change the tone.
Okay.
Yep.
So Amir suggests to reduce redundancy, and I'm echoing his suggestion. Later on in equations, there are also some repetitions. So it's not creative; it's more like hard work, but reading paper over and over and trying to catch redundant statements. Amir is asking to check whether letter A should be upper or lowercase, and probably lowercase would be fine, but just keep it doing every word. No. It looks like advertisements. Rabbi is a person, so it's uppercase. Are there any emerging questions to Mead's method section? Maybe general comments, because it's quite long and maybe one need. You do have general comment.
Too much detail, I guess.
Okay. Yep. Hey, Aaron? No comments. Amir?
Just due to the mentality we have is we write a lot at first and then we get rid of what we don't need. And so
Yes.
this is exactly what I would anticipate.
I support it, and I suggest the following plan. So let's try to polish methodology, even with understanding that we are going to shorten it, but make it logically
Yeah.
consistent, consecutive numbering, reduce redundancy, and there are standard tricks like cut 70% of the methods and place them into supporting information. But it doesn't mean that it should be low quality writing. Let's keep it here and polish it that it will be readable and we are able to submit it in a main text. But at the last minute, we may agree to move it into another section. This is discussed later, but as a reader, I do not see the connection between oscillator strengths and molecular dynamics. But oscillator strength helps to select initial excitation. Putting Hamiltonian of Fock operator is always great for definitions, but as an approximation, later on we neglect non-divided. Equation 2a looks identical to 15, and why one uses 2a. So while polishing and removing redundancy, please consider to use consecutive numbering, like 1, 2, 3. This 2a is not a good style. I accept it, and it was my fault. Last half an hour before submission, I inserted one more equation and I was lazy to renumber all references. Therefore, I just put A and B. But it's do not follow me. It's a bad practice. So try to use consecutive. Yeah, this is assumption. And it's not bad to mention Liouville von Neumann, but the Redfield operator is from later on, so all this part is assumed to be 0, so no dissipation. So just keep it in mind, and if one needs to sacrifice some details, maybe this Redfield tensor is the first candidate. It's a cool thing, but it is not used here. Definition is reasonable, and again, I would use consecutive if possible. And now we come to the violation of consecutive numbering. So it should be like number 4 or whatever, 6, not 15. And also this scalar product of these vectors is the same as it was before. Yeah, here. So electric field times dipole, but electric field is like epsilon at one place and uppercase E not in the different. So just maybe let's try to polish and converge notations. And let me know if any help is needed. I'll be happy to contribute to this effort. I hope it doesn't look scary to change notations. Neil?
What are you suggesting? I continue with one you have highlighted now, or from the previous version?
So I cannot.
Just make.
I'm not taking the responsibility to dictate what to do,
Okay.
but I identify that it looks like a redundant repetition of the same information that was done before, and
Yep.
redundant like using different symbol for stuff that has been already defined.
Yep.
So before it was Greek epsilon lowercase for this. Those equations are really relevant, and we even may have different opinions with co-authors. They're not really what is done, but I believe these equations help to reader to understand what is done in principle and describe what should happen even without our approximation. Okay. Continue consecutive notations like 19, 20, or whatever. This is a main equation that shouldn't be sacrificed, should never be sacrificed, even if you move everything to the supplemental, we will proudly carry Newton's equation of motion. Reference to figures 5 and 6 doesn't seem relevant here because it breaks consecutive numbering. I suggest just tell in what follows we use different methods to evaluate bond lengths. But when the manuscript, after the manuscript is typed, is accepted by editors and reviewers, it is forwarded to editorial office for typesetting. And typesetting team does whatever was your original version. They place figures in the place where they were cited. And they look literally in text where a figure is cited for the first time, there they put it. And if they put figure 5 at this place, then it is a question why it is figure 5, not figure 1. And then it will create a scramble and difficulty in logical understanding. For some people, logical arrangement is even of higher priority than scientific virtue. So let's keep it. What about dissimilarities? It is a question of even. So, the results. Let me ask other questions to meet about results and discussion. Something emerging that we need to focus on in general. So,
I think this comment could be expanded on what I previously had mentioned, where we had differing trajectories. We just highlighted a couple that correlated well with experimental data, and then in his case, if we'd say dissimilarities, we could say, well, the other trajectories that turned out to be not as coinciding with experimental data, then therefore that was kind of where we could explain the similarities do occur here and dissimilarities occur there. Possibly, or would that expand too much?
Even does it address your question in adequate form?
I guess maybe here you just need to change the wording a little bit.
Okay.
Okay. Would the word analogies?
Yeah.
Okay.
So rather than similarities,
Yes, similarities are a very strong word, and analogies gives some error bar room for breathing.
Okay.
Like rabbit and horse are not similar, but they have analogies because they all have 4 legs. I'm not sure if it makes sense, but maybe it is. Okay.
Okay, yeah. You guys taught me a little more about the English language here, because I didn't realize there was much of a difference between those two.
No, no. Thank you for the comment. I think what we practiced a minute ago, it's a subject that I'm not literate in, but it is what comes into the name of degree. Doctor of philosophy means someone who finds this little differences between analogies and similarities. So, Yvonne, can you please comment about your question?
I guess my concern is, I guess in the density of states, is that the water molecule does not change the symmetry of the orbitals. So if this is true, then why the absorption here is different because of water? Because in our absorption calculations, what really matters is just the shape of orbitals, because we calculate the overlap, right?
Does it make sense for you?
Maybe, yeah, how about we clarify this? I had thought that just due to the interaction of water and the molecule that we're photo irradiating, we would see some sort of reducing of the electronic transitions. That's what we had seen. So I'm just saying that interaction would influence it. But then, is there details I'm supposed to be emphasizing when suggesting that? Is there something I really need to be avoiding when suggesting that?
I think what you want suggest, you interpret his question correctly. Details. Yvonne, does me interpret question in a constructive direction?
Mm-hmm.
So let me try. can be wrong as well. But so details how presence of the water affects electronic transitions can be verbalized in the following ways. The energies of involved orbitals do not change drastically, but shape of the orbitals change to such extent that would modify transition dipoles and oscillator strengths to change the optical transitions in the noticeable extent.
Okay, that's why we would see differences on, I believe it was figure 3, just the different orbitals throughout our trajectories, right? Okay. Okay.
You want would you criticize my wording? Or it is more or less in the right direction?
I'm not sure I understand. Can you just repeat?
So there are two different ways how the water may affect electronic and optical properties. First, it may update the energy of orbital of certain symmetry. And second, it may change the shape of the orbital or hybridization even without making a direct chemical bond.
Yes, I agree.
And change, even small changes in the shape of the orbital may lead to drastic consequences in the transition dipoles and oscillator strengths which involve this orbital.
Mm-hmm.
Okay. Yeah.
Same like in the lanthanides, when it's not energy but slight crystal field slightly changes shape of orbital and makes drastic change in the transition dipole. Okay, and although we are not typing it, I believe it will be recorded. So if needed, we need to refer to some suggest cosmetic changes. I also have, not as a scientist, but as a bureaucrat and maybe future administrator, two things of organizational. First, why don't we try to number these chemical equations on the same line as mathematical equations? If before we had up to like equation 20 or 25, this will be 26 and consequent 26, 27, and so forth.
Okay.
If you arguments against, I'm fine, but I'm just suggesting. And use only the equations and figures and tables, no schema, otherwise too many objects. Second, I have forgotten what my second was. I'll try to remember. Whew. So I believe there are two questions from Yvonne and Aaron which refer to the same question. What or related? What are oxidation states for terminal, and is this monomer charge neutral?
I guess I was trying to. Okay, there's two things. When you're talking about the charges, I can't tell personally. Maybe you guys do know offhand. Like when a bond breaks, let's just say on our trajectories, I don't know if there's actual like a radical or some sort of ion at whatever end. But so, for example, this dimer unit by itself, my assumption is it's neutral immediately. I know it technically isn't, but I don't know what exactly is happening within our trajectory to show the electrons, whether it's neutral, positive, or negative. Beta charge? Okay.
We do not have time to commit new calculations for this paper, but there is a way to be more certain about charges.
Mm-hmm.
And if you ask Yvonne gently, maybe he will agree to help suggest how to practice this technique. Oh, I remembered my second thing. I mentioned it in the abstract, but there could be an epic confuse between authors of the paper and reviewers with the colloquial language for wet monomer and dry dimer. This terminology confuses reader drastically. Like here in the group, we designed this pseudo terminology to refer to infinite polymer with just few number of monomers in the periodic cell with periodic boundary condition. But if experimentalist or theorist who works, for example, with non-periodic software like a Gaussian, if he or she hears the word monomer, he or she will be furious, telling like, what does it mean? They're telling about depolymerization and they already start with monomer. So between us, it's a really good way to process forward, but one needs to design terminology or explain that under word monomer, we do not mean monomer. Make sense?
Yeah, with the wet and dry, that needs to be
Wet and dry, yes. But monomer and dimer, I admit my guilt as a contribution to this confusion, but we need to fix it before submitting. Maybe just telling model 1, model 2, maybe, but it's a little creative task.
Well, we would have to see, because when it's first said to me, I understood it just due to the polymer side of things. I understood it immediately, so there wasn't any necessary confusion. So I don't even know what exactly is the main concern, because I didn't have issues with it either. So
you are bright in your minds.
okay,
And you were.
all right.
You did this calculations, but reviewers often take it as unpleasant assignment and do it in a short time under pressure,
Okay.
and do not give authors benefit of the doubt. So they assume the worst possible scenario, and we shouldn't give them this chance.
Okay.
And we need to finish soon. Although there is no class today, I already made promises to several appointments later on, but let's maybe check. Here I'm just joking. The same word.
Secessions. That was pretty funny.
So in this chemical equation, Yvonne is asking where does hydrogen comes from?
Can you point on the mouse where he's talking about? Yeah, CHO on the equation 3 or equation 4?
Equation 3.
Equation 3.
The reactant.
Yep.
The left side, you have carboxylic group, and you have hydrogen.
Here?
No, to the left.
You're talking about the Fran, like the left portion of the Fran?
To the reactant, to the left. To the left.
Oh, to the left, to the left, to the left. Okay.
To the
that
left.
That OH?
To the beginning of the structure.
Here?
Right here.
The OH.
Oh, the very first hydrogen.
Yeah.
One moment.
It's already present in equation,
yeah.
but still it is it's not clear.
Yeah, I showed that it just cleaved the nitro benzene group from the other portion of the dimer. And I left on that oxygen. I can check again where that's coming from, whether that has become a CH2 and that nitrobenzene of equation 2. Maybe the OH, that oxygen holds on to one of the hydrogens from that trajectory. But I can check again.
Okay, yeah, please do.
Yep.
So it's interesting and important on one hand, and we do not want the reviewers to catch us on inconsistency on the other.
I can check.
Okay, so I'm asking everyone if you could maybe stop here and continue next time. Okay. So maybe we'll continue discussing Meet's work, and for everyone else, we have just letter to the editor to compose and maybe slide the format and to implement comments and format to the journal style. We may discuss in private which journal if it is not clear. Let me leave. Okay, and I believe the recordings was on. So after we are done, maybe by the midnight or during the night, I'll share if there were something was said and not typed. Maybe something can be contributed.
For this break period, is it simply okay if I continue on with my planned edits?
Oh yes,
and just simply resend to you. Yeah, okay.
yes.
So,
And as you, if the comments before seems logical and resolved to you, you may consider to implement them.
Mhm.
So it's very healthy draft. It will need a couple of iterations for polishing
yep.
in both content and formatting. So it's definitely like 80% done, but it doesn't mean that this remaining 20% can be skipped.
Yep.